This is about definition of function. What is a function? An equation or table represents a function when each input value is matched with exactly one output value. So example number 1. Determine whether the relation represents as a function of x. So this table is given. We want to see if it's a function or not. So look at all the x values. If they're all different, then every input value, these are inputs, is matched with exactly one y value, which is the output value. So looks like all these x values inputs are different. So therefore, this table represents function. Example 2. So this is another table. We want to determine whether this relation represents y as a function of x. So again, we look at the input values, x values. They have to be different. But no, we have it. This is -1 and this is -1. So these two values are same, but their outputs are different, which basically means for one input, -1, there are two outputs, and that is not a function. So this table does not represent function. Example 3, y equal to square root of 9 minus x squared. So we can determine whether this represents y as a function of x. So let's see. So looking at this equation is already solved for y. So for every x value I put here, we get one y value. So for example, if you put x equal to 0, so you have square root of 9, which is 3. So for input x equal to 0, the output y is equal to 3. So this means for one input, there is exactly one output. So therefore, this represents function. So the answer would be yes. Example 4. Y equal to 3. Does this represent function of x? Yes, because to each value of x, there is exactly one value y. That's a constant. No matter what x I choose, the y is going to be always 3. So this represents a constant function, and so it is a function. Example 5. X minus 3 equals 0 represent y as a function of x. The graph of x minus 3 equals 0 or x equals 3 is a vertical line. So for every x equals 3, there is an infinity y values of y. So we say x minus 3 equals 0 does not represent function. Example 6. Finding the values for which f of x equals 0. So f of x equal to x squared minus 5x minus 14. We want to find out for what x values this f of x equals 0. So all you have to do is set this to 0. Now we have equation x squared minus 5x minus 14 equals 0. Now we factor this one. The factors are x minus 7 and x plus 2. Set each factor to 0. X minus 6, 7 equals 0. Then if we move the minus 7 to the right, x equals 7. Similarly, x plus 2 equals 0. Then x equals to what? -2. So the answer is the x value -2 and 7. For these x values, f of x equals to 0. Example 6. Evaluating a piecewise function. For the following piecewise function, f of x equal to -2x plus 3 when x is less than negative. F of x equal to x squared minus x plus 2 when x is bigger than or equal to -2. So let's find the function value at -2. So here the x is negative. So first we check -2 will belong to this inequality. So, or it belongs to this one. It looks like If I say put negative 2 here, so it will become negative 2 less than negative 2, which is not right. But if I put x where the x is negative 2, so negative 2 greater than or equal to negative 2. So negative 2 is equal to negative 2, which is true. So therefore, to find f of negative 2, I'm going to use equation f of x equal to x squared minus x plus 2. And now substitute x equal negative 2. So this equation becomes f of negative 2 equals to square of negative 2 minus negative 2 plus 2. Now we simplify. Square of negative is 4. Negative is plus 2 and plus 2. And so 4 plus 2 is 6 plus 2 is 8. So therefore f of negative 2 is 8. So example 7. So we have piecewise function f of x equal to negative 2x plus 3, x squared minus x plus 2. Now we find f of negative 1. Now f of negative 1 means x equals to negative 1. And x equal to negative 1 is bigger than negative 2. So we use the f of x equal to x squared minus x plus 2. So we substitute negative 1. So it becomes f of negative 1 equals negative 1 squared minus 1 plus 2. Square of negative 1 is 1. Negative 1 is plus 1 and plus 2. So total is 4. So we can say f of negative 4 equals to 4. Example 8. For the following piecewise function f of x equal to negative 2x plus 3, x is less than negative, x squared minus x plus 2 is x bigger than or equal to negative 2. So find f of 2. Well, f of 2 means x equals to 2. Now we use this equation because 2 is bigger than negative 2. So 2 satisfies the second inequality. So we use f of x equal to x squared minus x plus 2. To obtain f of 2, we're going to substitute 2 where the x is. And 2 squared minus 2 plus 2. 2 squared is 4 minus 2 plus 2. 2 cancels. So f of 2 equals to 4. So the answer is f of 2 equals to 4. Example 9. For the following piecewise function, f of x equal to negative 2x plus 3, x is less than negative 2. X squared minus x plus 2 and x is bigger than or equal to negative 2. Now we're going to find f of negative 3. Now f of negative 3 means x is equal to negative 3, and for x equal to negative 3 is negative 3 less than 2. We use the second function. F of x equal to negative 2x plus 3. So now we substitute where the x is negative, so f becomes f of negative 3 equal to negative 2 times 3 plus 3. Negative 2 times 3 becomes positive 6 plus 3, which is 9. So f of negative 3 is 9. Example 10. Find the function value, if possible, f of x equal to square root of x plus 6 plus 3. So let's find f of negative 6. So it becomes, with the x is put negative 6, we have negative 6 plus 6 and square root of that plus 3. Negative 6 plus 6 is 0, so square root of 0 plus 3 square root of 0 is 0, 0 plus 3, so the answer is f of negative 6 equal to 3. Now let's find f of 3. So you put 3 where the x is, become 3 plus 6 square root plus 3. 3 square root of 9 comes plus 3 square 9 is 3. 3 plus 3 is 6. So let's use the same equation to find f of x minus c. So where the x is, we'll put x minus 6 to use this becomes x minus 6 plus 6 and plus 3. Minus 6 cancel, gives you square root of x plus 3.